Hello friends, today we will discuss Heisenberg's uncertainty principle. Okay, first let us try to understand the statement or the meaning of Heisenberg uncertainty principle. According to this principle, it is impossible to measure the exact position and momentum of a particle simultaneously within a wave packet or group. It is impossible to measure the exact position and momentum of a particle. That is, we cannot measure the exact position and momentum of a particle at same time within the wave packet. Okay. In de Broglie concept of matter waves, we have discussed that whenever a particle moves, that is, the matter has a dual nature. When it is in the state of rest, it shows the properties of particle. When it is moving, waves are associated with it. Okay. Now we know group velocity of the wave packet is given by Vg equals to delta omega upon delta k. Okay, what is de Broglie concept? When the particle is in the state of rest, it shows the properties of particle. When it is moving, waves are associated with it. And with a single particle, when it starts moving, there are a number of waves associated with it. And within this wave group, we cannot measure the position and momentum of a particle simultaneously at the same time. Okay, so let us derive the result. Now, group velocity means the velocity of the group of waves. Okay, where here omega is the angular frequency, k is the propagation constant. Omega is the angular frequency, 2 pi nu is the frequency, k is the propagation constant, 2 pi by lambda. Okay, and k is the propagation constant of wave number. Fine. So Vg, the group velocity is equal to the particle velocity, because due to this particle, group came into existence. Okay, so Vg equals to V equals to delta omega by delta k. Equation number 1. Now, as omega is equals to 2 pi nu, therefore delta omega will become 2 pi delta nu. Okay, equation number 2. Propagation constant or wave number is 2 pi by lambda. Okay, and de Broglie wavelength, lambda is given by h by p, de Broglie wavelength. Please see the video lecture of the quantum mechanics. Okay, my earlier video lecture, de Broglie wavelength. Okay, lambda is equals to h by p. Now putting this value in equation of k, so we will get k equals to 2 pi p by lambda, or delta k equals to 2 pi delta p by lambda. Equation number 3. Now put equations 2 and 3. Put equation 2 and 3 in equation number 1. Okay, so put equations 2 and 3 in 1. Okay, so we will get V equals to 2 pi h delta nu divided by 2 pi delta p is equals to h delta nu by delta p. Equation number 4. Now let the particle, suppose the particle covers distance delta x. Suppose the same particle covers distance delta x in time delta t, then velocity is given by delta x by delta t, that is rate of change of distance. Okay, rate of change of displacement. Okay, so compare equation 4 and 5. Compare equation 4 and 5. We will get delta x by delta t equals to h delta nu by delta p, or delta x delta p equals to h delta nu delta t. Okay, equation number 6. Now frequency is related to delta t. One of the relation is that delta t is equals to 1 by delta nu, because they are reciprocal to each other. Another one is that delta t may be greater than or equal to 1 by delta nu. Okay, these both are very general relations. So equation number 7. Equation number 7. Now hence equation number 6 will become, if delta t is greater than or equals to 1 by delta nu, then equation number 6 becomes delta x delta p greater than or equals to h. Okay, this is Heisenberg's uncertainty principle, but there is more sophisticated derivation or relation of Heisenberg uncertainty principle, which shows that delta x delta p equals to h by 2 pi, or this equals to h cross, where h cross is equals to h by 2 pi. Okay, so as the particle is moving along x-axis, therefore the momentum in equation 8 of Heisenberg's uncertainty principle should be the component of momentum in the x direction. Therefore equation of Heisenberg uncertainty principle can be written as delta x delta px equals to h by 2 pi. This may be equation number 8, this may be equation number 9. Okay, there cannot be any uncertainty if momentum is along y direction. Okay, because here we are assuming the particle is moving along x-axis only. Okay, so this is all about the Heisenberg uncertainty principle. If you have any doubt, please share in the comment section. Thank you. Thanks a lot.